epinephrine. Where do we get that? Okay. Well, in the body. Can you think of where that might be related to? Huh? Which one? Wait a minute. Did you mention that earlier today? The old adrenal gland. Where is it? On top of the kidney. It's the triangle. Alright? And it's going to be the medulla portion. What types of activities in the body take place when we hear epinephrine?
Like
No, like, what does it help us do? What does it do to us? Oh, yes, it's feel good. Alright? You know, it's sort of like people who exercise, the reason they're doing it, they get to feel good endorphins, which is epinephrine. That's pretty good to have been interesting. What? That's going to be interesting too. Now, here's a big difference. The effect of those transmitters. They can either be excited or inhibited. This means it could either cause the effector, which would be the organ, to do something, or it could stop it from doing something. So they're going to be called excitatory or inhibitory. Depending upon which system, and then that neurotransmitter will either make it be an excitatory effect or an inhibitory. So it's going to go along with the two divisions. Okay, so quite a few differences now between what we know up to this point about the skeletal muscle and what's going to be happening for the inside of our body. So, now, the two divisions. Autonomic, when we look at it, we've got that sympathetic and parasympathetic. Sympathetic, we usually associate with excitation. Parasympathetic, calming it down. Look at what this tells me. Let's take the terms apart. The sympathetic division, also termed thoracolumbar. What two regions of the spinal cord are they telling me this sympathetic division is associated with? My thoracic and my lumbar. Wait a minute. What about the other region? That's okay. No, it's telling me that nerves that will exit are only going to be found in the thoracic and the lumbar region. They're letting me know something about my axons, the fibers. They're letting me know where the neurosoma is located. What's the neurosoma? The nerve cell body. Telling me in the lateral horn. Do you guys remember me mentioning that when I talked about the spinal cord? The lateral side, the lateral portion is what is involved with the autonomic nervous system. It's letting us know that those fibers exit by way of the spinal nerves strictly in the thoracic, the lumbar region. They lead to my chain ganglia, the stuff that I tried to point out. These are a series of longitudinal ganglia, the bumps, okay? In the cervical region, usually have 3, 11 in the thoracic, 4 in the lumbar, 4 in the sacral, 1 in the coccygeal. Sympathetic nerve fibers go to they go to every level of the body. What does that mean? They're showing us in this area the chain that runs along the bones of the the bones of the spinal column. They tell me that the fibers for the sympathetic division serve every area of the body. Meaning, the sympathetic division affects every organ of the body. It is either going to be an excitatory or inhibitory response. And the digestive organ is mostly inhibitory. Bladder, mostly inhibitory, but that doesn't mean that it doesn't get excited. All right? Kind of backwards to me. Let's take a peek at this picture. Because this picture can pretty much explain everything for my sympathetic division. Let me see here. They're trying to show me the regions of my spinal cord in different colors, okay? They're trying to show me my cervical region, thoracic region, lumbar region, sacral, okay? They're trying to show me my regions. We said the sympathetic is known as the thoracolumbar. It is showing me here exiting 4 fibers in the thoracic and lumbar region. Is everybody following me? It also told me that those fibers leave by way of those spinal nerves and make their way through or to the chain ganglia. Is everybody following me? This was the chain that I tried to represent on that model, just outside of the bone. Let's look at what it's doing. This is my sympathetic division, and it said that it innervates everything. On the left-hand side, they are showing me innervation to my skin. Has lots of receptors. On the right-hand side, what do you notice? Everything else. It's showing eyes, nose, mouth. What's that have to do with homeostasis? Why in the world would there need to be innervation to the eyes, the nose, the salivary gland? When the sympathetic division is functioning, and because this is the division that prepares me for fight or flight, do I need my pupils to dilate or constrict? I need them dilated, because I need to have as much light entering my eyes as possible, because I need to see the enemy coming at me and all of my surroundings. Because in reality, that is what these divisions are based upon. They are based upon the danger, meaning the sympathetic, or not the parasympathetic. In the cases of danger, I need to have as clear a vision as possible. So the sympathetic division will get those pupils as big as possible. But now wait a minute. What's the smell? It will enhance the smell so that you can smell the danger coming at you. Wait a minute, what about the salivary gland? Part of the digestive system. I need it to be free. Because I'm not worried about eating, putting food in my mouth to break it down for it to go in and be digested. Because if I've got to face the danger, I doubt very seriously I'm facing the danger of eating a donut. I could be, just saying, because hey, put me around fried dough, that's just a bad thing. So, but for the most part, we're just focusing on the danger. Now, heart, lungs, got a connection there. What do you notice being present for the remainder of the organ? Do you see something present that isn't present as we went up the chain ganglia? Alright, y'all are noticing something different about the green and the red, because they're trying to show us a difference in what's going to be my pre and my post. Y'all notice the difference between the fiber length. Do you notice anything else?